Hello students, welcome to this lecture number 6. In this lecture, we will be going to discuss the basic properties of the aromatic amines. This is basically in continuation of our previous lecture, where we have discussed about different aspects of the basic strength of the aliphatic amine, aromatic amine and ammonia. And we have understand one very basic fact that aliphatic amine having the highest basic property as compared to the aromatic amine and ammonia. So in this lecture we are going to discuss one very important thing, that when we are going to incorporate some electron withdrawing groups or electron donating groups in the ring of the aromatic amines, that is in the benzene ring, that is in case of aniline, that we will discuss the things in case of anilines, that when we are going to incorporate these electron withdrawing groups or electron donating groups, how that will going to affect the basic strength of the aromatic amines. So heading of today's lecture is the basic property of aromatic amines and its impact of the different groups, that is electron withdrawing groups and electron donating groups. This is KTM Mukherjee in the Science with Mukherjee YouTube channel. We know the aromatic amine have the lowest basic strength. As for example, if we take the pKb value of the aniline, it is around 9.35, as against the aliphatic amines, its pKb value is less than 4. So you can easily understand the basic strength of the aromatic amine in comparison to the aliphatic amine, and that is due to this reason of the plus R effect of the groups, that is the amino groups that is directly joined to the basic link. Now we will discuss that impact of the electron withdrawing group. We know some groups able to contribute the electrons, that we will call it is a plus R effect of plus I effect, because their capability of giving the electrons to the source, and there are this type of groups, that is electron withdrawing groups. So we are now going to discuss the impact of electron withdrawing groups. Impact of electron withdrawing groups. Electron withdrawing groups is like NO2 is one of the electron withdrawing groups, or we can say chlorine is also a electronic withdrawing groups. When this has been incorporated in the rings of the aniline, at that time what will its impact on the basic strength, that we are going to understand. General rule is this: when we incorporate the electron withdrawing group in the aniline, it will going to contribute in the negative way, that is the basic property will decrease. So we can write the basic property will decreases, means basic strength will going to decreases. Basic strength, we can say the basic strength. Basic strength is basically measured by pKb value, and we also write this pKb value. So basic strength decreases. Why it is decreases? Because it will withdraw the electrons from the benzene ring, and as a virtue The basic property of the aniline is due to the lone pair of electrons over the nitrogen, and this will be demanded, more demanding towards the benzene ring. It will donate the electrons to the benzene ring. So this electron, lone pair of electron, will less available for sharing with the protons of the acid. That is why it will have the less basic property. But we will understand these groups, NO2 groups, will have a impact in which position this has been incorporated. So first let us understand the NO2 and Cl group. This is para nitrotoluene. So in this case we will arrange in decreasing order, that we will first give the species which have the highest basic property. So this is first we will give the aniline, because basic strength will going to decreases. So aniline and the pKb value we know that is 9.35, and its basic property will be higher than the, then comes the meta. This is meta-nitroalanine, and basic pKb value we will write it down afterwards. Let us understand this is meta-nitroalanine, M-nitroalanine. And then para-nitroalanine. This is para-nitroalanine. And last we will see this is a basic strength is very low, that is orthonitroalanine. So here if we write the pKb value, it is like this. pKb value of this is meta-nitroalanine. This is pKb value that we can write it. It is 12.64. Then pKb value of this para-nitro, pKb value will be 13. Then orthonitro, it will be 13.22. Okay, this is the pKb value. So from this pKb value we can actually understand that meta-nitroalanine having the higher basic strength as compared to the para-nitroalanine, and orthonitroalanine have the lowest basic strength. And question arises, why the meta-nitroalanine having the higher basic strength as compared to the para-nitroalanine? This is because of this fact, when it is in these positions, at the meta position, at that time we can write why meta-nitroalanine having the highest basic strength as higher basic strength as compared to para-nitroalanine, because of this fact. At this position, when this nitro group at the meta position, at that time minus R effect is not strong. Minus R effect is not strong. That is, we are talking about this that is meta-nitroalanine having the higher basic strength, because the minus R effect is not strong, only minus I effect, that is electron withdrawing effect, is little, and that is why it have the higher basic strength as compared to the para. So you understand, when the position is changing, that is going to impact also. And the ortho position, we will see, it is having the least basic strength. So it is not like only we are incorporating the electron withdrawing groups, but position is also a very important thing. Now we are going to take for the chloro group. When electron withdrawing groups is chloro, at that time also we can see these aniline will be the highest, followed by, in this stage, para-chloroaniline. Para-chloroaniline will be the highest basic strength as compared to the meta-chloroaniline. And this is ortho-chloroaniline have the highest. So if you see the pKb value we will find for this, it is pKb value of the aniline is 9.38. Then pKb value parachlor is 10. Then metachlor is 11.32, and it is orthochloroaniline, it is 13.3. So here what is going to happen at the position, when it is in the para position, at that time what is going to happen, the plus R effect and minus I effect both will be operative. Small questions in the MCQ comes, there will different options will be given, and we have to say what parachloroaniline is greater, basic strength is greater than metachloroaniline. At that time we have to remember this very important fact, it is the plus R effect is also minus I effect, this is both are operative when chlorine at the para positions. So you can understand, it is very interesting. That is not important that we are incorporating the electron withdrawing group and it will going to decrease the basic strength. This is the general rule, but the position is also going to impact. And the ortho position, you can see always, that is the derivatives are less basic strength, and this is also called the ortho effect. Okay, we are going to discuss the impact of electron donating group. Impact of electron donating group. Electron donating group. Electron donating group, that is CH3 methyl group or OCH3. OCH3 is methoxy group. What is impact that we are going to understand? So the general rule is, when we incorporate these electron withdrawing groups to the benzene ring, it will going to increase the basic strength. So we will write it will increase the basic strength. Basic strength will be increased. How? But again, the fact is in which position this group has been incorporated, that is going to impact also. So for that, first we will see the para-toluidine. It is having the highest basic property that we will see later on. We will put this value. Para-toluidine is greater than the meta-toluene. When this group is put at the meta position, this is meta-toluene. Okay. It is also is higher than the aniline. Now there in the position where we are arranging in the decreasing order, we will find the aniline will come first. After that, this group will come. Ortho-toluene will come last. Okay, this is aniline and ortho-toluene. Now what is the pK value? pKb value you see for this para-toluene it is 9.21 and it is 9.34 and it is 9. Aniline having the 9.38 and it will be 9.58. Okay. So we understand this is the impact. Para-toluene, then meta-toluene, then aniline, and ortho-toluene is coming on the last. That is having the lowest basic strength. Now we will be taking this electronic withdrawing groups, that is methoxy group. Methoxy group is this. First, that you will find the para OCH3 group. This is para-aniside. Para-anisidine. Para-anisidine, and it is followed by the aniline. You can see in this case, aniline will come second. CH3 aniline. Then it will have the highest basic strength. The next basic strength will come to the ortho OCH3 group. It is ortho-aniside. Aniside. Then it will come it is a very interesting thing to know, at this meta-aniside. Meta-aniside. So you can see meta-aniside having the lowest basic property. In spite of this fact, it is a electronic withdrawing group, but its position is different. When we put this methoxy group at this meta position, what is going to happen? At that time, very less plus R effect. Plus R effect is not operative at that position when this methoxy group has been put in the meta position. And at that time, the minus I effect is operative, and that is why although it is changed to the meta position of this benzene ring, it will act as the electron withdrawing group, not as an electron donating group, and that is why its pKb value will be very, very less. So what will be the pKb value? Let us understand. Let us see. pKb value of para-aniside, it will be 8.71. Okay. Then aniline we know that is 9.38 or 9.35. Ortho-aniside having the pKb value is 9.51 and the meta-aniside it would be 9.8. So we understand the group position of these groups. You can understand that is also very important for determining the basic strength of the substituted amine. So we understand from this discussion that when we are incorporating electron withdrawing groups, it will going to decrease the basic strength in general, but when the position is changing, it will have some impact. We will find that at the para position, the impact is very high. Impact is much more as compared to the ortho or meta position. And ortho position you will find whether we are incorporating electron withdrawing group or electron donating group, that is not the matter. Irrespective of that, it will going to give the lesser basic strength. So this is called the ortho effect. So we understand the impact of the electron withdrawing groups and impact of the electron donating groups. Okay. So we will now understand when we we are putting the electron withdrawing groups or electron donating groups in the ring. When we will substitute the hydrogen atom of the amino group by any electron withdrawing group or electron donating group, what will be the impact on the pKb value, that we are going to discuss now. We are now discussing why we are substituting the hydrogen atom. At that time, what is going to happen? This is, we can write with the decreasing basic strength, that we will find when we are replaced the two hydrogen atom with the methyl group, it will have the highest basic strength. Followed by when we are replacing one hydrogen atom by methyl group, it will be this, and the aliphatic aromatic aniline will have the least basic strength. And now if we replace the hydrogen atom with this phenyl group, which is electron withdrawing group, at that time what is going to happen? It will be just reverse. You can see C6H5NH2, the highest basic strength, followed by C6H5O2NH, that will replace one hydrogen atom by C6H5, that is phenyl group. And when we are replacing all the hydrogen atom with this C6H5 electron withdrawing group, so it will have the least basic strength. Okay, so that is all for today's lecture. In this lecture, we have discussed about the impact of electron withdrawing groups and electron donating groups on the basic strength of the aromatic amine. And in the exam, you will find small questions, 1 number questions, that is going to come, and you will be given different. Suppose you will be given why meta anisine having the lowest basic property. At the time, you have to remember that at that position, the plus R effect is not operative, only the minus I effect is operative. And likewise, we have discussed many exceptions and many important informations in this lecture. Hope you understand all the points. If you have any doubts, you can comment on the comment sections. And we will meet in the next lecture, that will be the last lecture, with the diazonium solid. Thank you very much for watching. If you like this lecture, you can share to your friends. Thank you.